Let's move on to interpreting SPS output. And we're going to use the example that's in the textbook. In SPSS, the resulting regression output looks like these three tables. So you're going to get these three tables. You can get some additional information, and we'll talk about that a little bit later, and about some additional runs and options that are useful. But let's look at this example from the textbook. So this is figure 4.7 from the text. And you can see that you have your predictions for R, and you have your R squared value. You're given an adjusted R squared value. We're not going to worry about that right now. We can talk later about how we interpret that, and then a standard error of the estimate. The standard error of the estimate is used to construct confidence intervals, but we don't really need to do anything with this for interpretation. So what does the R squared value tell us? So this is what we're interested in. What does, from this table, from the model summary, we're most interested in our R square value. So what does the R square value tell us? It tells us that our model explains 27.7% of the variance in income. So school and age together explain 27.7% of the variance in income. So figure 4.8 is our ANOVA table. So ANOVA stands for analysis of variance. And it includes the sum of squares, the degrees of freedom, and the mean squares, right? This is also an ANOVA table, and it gives you the significance level as well. So you have your F value and you have your significance level. Allison points out that the significance level is really the only important thing to look at in this table, because it is our test against the null hypothesis that all the independent variables are zero. So remember that a small significance is a good thing, and that if we have a significance number that is less than 0.05, that means that at least one of the independent variables is having an impact. So it's not testing the independent variables separately, it's testing the overall model. And it is telling us that in the regression model, at least one of those independent variables has an impact, that it's not zero. So that's good. And the degrees of freedom in the regression model represents the number of independent variables in our equation. And so that number, it has to be fewer than our total number of observations, and that becomes important. So we had 34 as our total N, right? That's the number of cases. We had 2 degrees of freedom because we have 2 predictors, right? 2 independent variables, school and age. So our degrees of freedom is going to be 2. And so it's based on the number of independent variables in the equation. So let's look at figure 4.9. So we also get a coefficient table that provides us with both unstandardized and standardized beta coefficients. So our unstandardized coefficients are those numbers that we are going to put into our resulting equation, right? So our unstandardized coefficients. Our standardized coefficients are our normalized coefficients, and it gives us in standardized standard deviation units. So that becomes an important factor. We talked about how sometimes the variable can look like it's very large if you look at school, right? So the unstandardized coefficient for school is 2056.96, right? So what does this mean in terms of income? So we're talking about for every increase in school, so for every additional year in school, we get an increase of $2,056, okay? But because that is such a huge coefficient, because the metric for measuring school and income are very large, then these standardized coefficients give us a sense of comparison, right? So actually, and our significance levels tell us this too, but that age has a bigger impact than school does because the beta coefficient is larger. And our significance levels bear that out too. So we're given our t-values and our significance levels. You can ignore the t-value for the constant. That doesn't make any sense. It's not really interpretable. But we have our t-values and our significance levels, and we can see that both of these variables have a significant influence on the dependent variable income. Okay? So what is the resulting equation for this model? So how would we write out the equation for this model? Well, we would write it out like this. So this is our constant, our value from here, plus our slope for age, and we have our x sub h, plus our slope value for school. So we have that value and our independent variable school. So this is how we would write out our resulting equation. You are almost never going to be asked to write out the equation in published writing, but I still think that it's a good exercise to write out the equation just so that you can kind of see visually what that equation looks like, and then you can think about how that might get plotted in terms of the graph or what that curve would look like.